In this question, a function f of x equal to 2x is defined from n to n. Here n stands for natural numbers. As we all know, natural number starts from 1 and it goes on till infinity. So f is a function which is given by f of x is equal to 2x. The question requires us to test whether this is unknown or onto or both. So first let's try to understand what is unknown and onto. So 1 1 function is something which says that every two elements in first set, let's say there is function f different from a to b. So if the function has to be 1 then no two elements in a, like a1 and a2, must have same images in b. Like if b1 and b2 are images of a1 and a2 respectively, then if b1 is equal to b2, then a1 must be equal to a2. So let's test here. Let's take some two natural numbers n1 and n2. n1 and n2, they belong to first set n. Then their images will be 2n1 comma 2n2. So if 2n1 is equal to 2n2, we can see from here that n1 is equal to n2. So the given function f is 1 1. So next let's understand what is onto function. So onto function says that every in the previous case f is different from a to b. Like if there are two elements b1 and b2 so on, or let's say b consists of some bn number of elements, then every element in b must have a pre-image in a. Like all the n images of which belong to set b must have like a1s and a2 and so on, ans, which, or maybe same pre-image which belong to a. There should not be any element in bn which doesn't have a corresponding element in a. Let's test, give an example. Set b is natural numbers here. So let's take number 4. Then if 4 is equal to 2n, then that implies n is equal to 2. This belongs to natural numbers. Let's take another example, but this time let's take an odd number. Let's say 7. If 7 is equal to 2n, n is equal to 7 by 2. This does not belong to natural numbers. So it doesn't belong to the first set, which means given function f which is defined from n to n is not onto. So can you tell any example which, like any two sets from which we can define the same function which can be both 1 1 and onto? Let's say from rational numbers to rational numbers. Let's check if it's fitting the description or not. F maps from rational numbers to rational numbers. So if we consider any two, like in A R, like first set R and B R, these are two sets of rational numbers. Let's take two R1 and R2 which belongs to A. R1 comma R2 which belongs to A. I mean A is R here, rational numbers, and their images will be f of R1 is equal to 2R1 and f of R2 will be equal to 2R2. We know this 2R1 and 2R2 are rational numbers. That means they belong to set B, rational numbers. So given function f is 1 1. And now in order to check for onto, we have to get from set B. Set B is again rational numbers. So let's take any two B1 and B2. So even if B is any random rational number, then rational number by 2, sorry, this rational number B by 2 will belong to A, which is again rational number. So that means every element in B has a pre-image in A. So F maps from rational numbers to rational numbers is both 119 onto.